All right, welcome back to class, everybody. Thank you for your attendance. We're going to pick up right where we left off last week. We were talking about an asteroid named Bennu and NASA's mission called ORISIS-Rex to send a probe, a spacecraft there, to bring back samples from this asteroid back to Earth. So what we saw in these samples is that they were made up of the same materials here found on Earth, such as salt, silicates, water, limestone, clay, olivine, iron, and nickel, and other matter found right here on Earth. And as we discussed, these are the compounds that are in our Earth's crust. And so according to hydroplate theory, we have now a mechanism that shows how these things would have gotten out in space from the bursting forth of the great deep and then be ejected out into outer space. But the most important thing probably that was found on Bennu, this asteroid, is that organic matter is found or was found on this asteroid. And I won't even pretend that I really understand this image, but it has something to do with it shows some of these compounds that are organic compounds that were found on this asteroid. And of course, this is an incredible surprise to the evolutionists to find this kind of thing on an asteroid. Of course, what they're finding here are nucleotides, what are called nucleotides and amino acids. So nucleotides are fundamental structures of units, and they're building blocks of what are called nucleic acids. And specifically, these are found in what's called DNA and RNA. And DNA stands for deoxyribonucleic acid, and RNA is ribonucleic acid. And this is what in our bodies stores and transmits the genetic information that makes us who we are. Okay, this is a code basically that it makes up of exactly who we are as human beings. And this is also found in animals and plants as well. So DNA is in all living things. And amino acids are organic compounds that serve as the fundamental building blocks of proteins. And they're essential for building and repairing tissues, producing enzymes, and they support metabolic functions. And it requires a very specific arrangement of very specific amino acids to produce a protein. It's very complex. I mean, this is all, astoundingly complex. And this is what we find in our own bodies. As you probably are all aware, all living organisms like us are made up of cells. A cell is the basic structural, functional, and biological unit of all known living organisms. And it's kind of like a little city. I mean, it's inside your body. It's of exceeding in complexity. And realize that you are made up of about 75 to 100 trillion cells. And I won't get into it too much deeper than that, but it is incredible when you start thinking about the complexity that is found in living things. So we find that the cell is a building block of life, and then cells combine to form tissues, and combinations of tissues comprise organs, and combinations of organs form organ systems. And they all work together to form a complete organism like us, right? So within all these cells are deoxyribonucleic acid, or DNA for short, which are these arrangements of nucleotides. It's a code, basically, that determines who and what we are and how you function. And it's incredible. And to find out now that sections of DNA, these nucleic acids, have been found on asteroids is pretty astounding. So I just want to briefly look at DNA for just a second. Here in this slide is a representation of only a small portion of a DNA strand. And it's been called the most compact and efficient storage system in the known universe. So the DNA strand within each cell carries the code information for every machine that operates within a cell, telling it what to do and what to make. So the DNA pattern that we see here is made up of 4 different parts, these nucleotides. So if you can imagine a set of blocks that only has 4 different types of blocks or shapes, or maybe an alphabet with only 4 letters, you kind of get an idea of what DNA is. DNA is a long string of these blocks, or these 4 letters or blocks, that are arranged in such a way to provide coded information. So a single strand of DNA, this will really blow you away, is around 3.3 billion base pairs long. So you look at these base pairs here, there's 3.3 billion of them in one strand of DNA. So if we took this little section of this piece of DNA that we're seeing here, and we expanded it out to its full length at this scale, okay, given that our TV screen is roughly, what, 2 feet-ish or so tall, if we expanded that out to the length that it really would be at this scale, it would be about 14,200 miles long. Okay, so let that just sink in for a second. If we imagine this was the end of the DNA strand and we just started going straight up, we'd go 14,200 miles approximately to get to the other end of this strand of DNA. Now realize that the Earth's atmosphere goes up about 6,200 miles. So this is over double the height of our own atmosphere on Earth. That strand of DNA now goes way out beyond Earth's atmosphere, way out into outer space. It's incredible. And it all contains an amazing code. It's very, very complex. So we put this in another perspective to let this kind of sink in just briefly, because I think it's kind of important to understand how important this really is. Carl Sagan, the famous scientist, he's actually an atheistic scientist, showed using simple calculations why one cell's worth of genetic information approximates what would take 4,000 books to print. In other words, if you took a book that had 500 pages each with 300 words per page, this information would take up about the space of 4,000 books. Now keep in mind, that's a single cell, right? That's one cell in your body, which you have somewhere in the range, again, of 70 to 100 trillion cells in your body. So if you had that all information of just one person recorded in these books, just how much space would that take up? Well, I'm glad you asked, right? If you take the height, width, and thickness of one 500-page book and calculated how much space that it would take up, it would come with around 50 cubic inches. Cubic inches, 1 inch by 1 inch by 1 inch. That's per book. Now, if you multiply that by 70 to 100 trillion, that's a lot of cubic inches, right? I mean, you're talking about a lot of space there. So how many cubic miles does that end up being? Do you have any guesses in here? Does anybody have any idea how many cubic miles that would take up that much space? Well, I'll tell you, because you probably couldn't guess anyway, right? 24,000 cubic miles. So that's the genetic information from just one person if it was written out in book form. Now to really make this crazy and make this even more in perspective, put it in a little bit of context here. It has been calculated that the internal volume of the Grand Canyon is 800 cubic miles. So approximately 800 cubic miles have been eroded away from the Grand Canyon. And we'll talk more about the Grand Canyon later in the class and how it formed. It's really fascinating too. But for now, we're just going to use it as a little illustration here. So we just saw that these books of one person's DNA would occupy about 24,000 cubic miles. So if we divide 24,000 by 800, okay, we can see that it's about 30. Therefore, if the DNA in every cell in one person's body were recorded to information in 500-page books, the total number of books it would take would fill the Grand Canyon 30 times. Is that amazing or what? I mean, I get emotional just thinking about it. Now realize that the DNA strand is so small, if you took a single strand of DNA from every person who has ever lived, in other words, if every person who's ever lived in the history of the world, and you took one strand of DNA for every single person, and you gathered it all together, it would fill about 2 teaspoons. Wow. Isn't that crazy? So you should now be picking up your jaws off the ground, right? I mean, I even brought in some paper towels if you want to, sop up the drool that you probably have underneath your seat. So if you have a puddle of drool under your seat, see me. I'll give you some paper towels. And we worship an awesome God, right? I mean, it's absolutely amazing. And it kind of gives a new meaning to that song we sing in church, How Great Thou Art, right? I mean, think about that for a minute. So contained in DNA is an amazing complex code. So in our experience, codes are produced only by intelligence, not by natural processes or chance, right? A code is defined as a set of rules for converting information from one useful form to another, such as in language, for example. So genetic material that controls the physical process of life is coded information. And also coded are the very complex and completely different functions. So we have the transmission, the translation, the correction, duplication systems when cells divide. Without this genetic information, all that's useless. It doesn't know what to do. And if that was the case, life wouldn't be possible. Life would cease. So it seems obviously the genetic the code and the accompanying transmission, translation, correction, and duplications all would have had to been produced simultaneously. In other words, one part without the other parts supporting it doesn't function, right? So this points back to creation, saying that, hey, this is exactly what God tells us during the creation week. Everything is formed immediately in fully formed, fully functional structures, plants, animals, us. This only comes from an extreme intelligence. I mean, this is such powerful evidence right here that you could use this alone, I think, to talk to somebody. So now we realize nucleotides and amino acids which make up proteins were found on this asteroid, Bennu. So how in the world do you think they could have gotten there? Right? Evolutionists will tell you that this material must have come from somewhere else in the universe, right? Earlier in class, I showed you a video of a young lady who was completely shocked and surprised at what they retrieved on these samples from these asteroids. I think if you've been in a class a little bit, you know how they got there, right? The fountains of the great deep burst forth and injected this stuff up into outer space. They coalesced and formed into asteroids, comets, and that's how they're finding this up there. And again, this is all in addition to material that we find here on Earth. So not just the organic matter, but all these other materials we've been talking about. So these incredible materials were found on Bennu during this mission. And there's actually a website called www.asteroidmission.org, which is a website that details this mission and its purposes. And on the site, they state the following as the mission of ORISIS-Rex. It says, ORISIS-Rex seeks to answer the questions that are central to the human experience. Where did we come from? What is our destiny? Asteroids, they state, are the leftover debris from the solar system formation process. And this is an assumption that comes out of evolutionary theory. It's not supported by any evidence anywhere, but this is the statements that they make. This is a deduction from necessity because they automatically reject any sense of a creator. So they think this is leftover debris from the formation of the solar system, and they said this can answer the questions and teach us about the history of the sun and our planets. So they go on to say, too, that the ORISIS-Rex spacecraft is traveling to Bennu, which is an asteroid, whose regolith, and that means its layer of loose materials on the surface, may record the earliest history of our solar system. Bennu may contain the molecular precursors to the origin of life in Earth's oceans. Bennu is also one of the most potentially hazardous asteroids, as it has a very high probability of impacting the Earth in the late in the 22nd century. So we're going to talk a little bit more about this too to follow, okay? But realize these asteroids have a chance of coming back and striking the Earth. And they know this. And we'll show you some examples of this too. So I put the word may in here in red and underlined it to show you this is not something they have a certainty on. This is a deduction again from an evolutionary position that follows from a commitment to evolutionary theory, and it's not really any evidence that these asteroids record the earliest history of our solar system. They can't even be certain that the asteroid contains the precursors to the origin of life in the Earth's oceans. Living things are so complex that we just talked about that making the jump from just a few nucleotides and amino acids to developing into a fully living creature is an amazing leap of faith. So even if that's somehow made it to Earth, it's still not even close to actually producing anything that would be life. I mean, again, it makes no sense. They have a much greater faith than we do, I mean, in this. I mean, I don't have enough faith to be an atheist, basically. So you need billions of pairs of nucleotides to make up even one strand of DNA. And if you have to have it function, it would have to be complete from the very beginning or it's meaningless. So this, again, none of this makes really any sense. So because one needs the other, the satisfactory explanation for the origin must also include the origin of the other. That's not there, though. One can't function without the other. So again, this implies creation, and everything came into existence fully right from the very, very beginning, just as the scripture tells us. So on the website, they also make this unscientific statement. It says, nature had the conditions to cook up the chemical precursor ingredients for life before the Earth formed, according to 2 studies published by Sample Analysis of the NASA ORISIS-Rex mission. So never is stated as how this happens. I mean, how could this have actually happened? They just state it, but they don't have any answers for how. And then a guy named Dante Loretta, he's the Regents Professor of Planetary Science and Cosmochemistry at the U of A Lunar Planetary Laboratory. So this is the University of Arizona right here in Arizona. It's kind of a $10 title for who he is here. He's the leader of the analysis team looking into these samples that were collected on Bennu, and he made this statement. He says, these samples from Bennu are an incredible discovery, showing that the building blocks of life were widespread across the early solar system. And how does he know that? Okay, he's making an assumption again. There's no evidence for this anywhere. Okay, but no, it's because we have a dedication to evolutionary theory. This must have been what happened, right? By studying how these ingredients interacted in environments like those on Bennu and in places inferred for early Earth, such as salty ponds, similar to those that Darwin once imagined, we can better understand how life might emerge and where to search for it beyond our planet. I mean, there's an awful lot of fuzzy words there. It's inferred, it might, you know. That's not how science works. This is not how science works. They only provide speculations. Okay, now we're going to look at another asteroid. This one is interestingly titled or named 162173 Ryugu. I don't know if I'm pronouncing that right, but R-Y-U-G-U. And it's called a near-Earth object, and it also is a potentially hazardous asteroid in that it might hit the Earth someday. It's part of what's called the Apollo group. The Apollo group are a group of asteroids that have orbital paths that could potentially cause them to cross very close to the Earth at some point, and thus could potentially do great damage to the Earth. And it measures about 3,000 feet across, to give you some sense of scale there, so a little over half a mile. And in June of 2018, a Japanese spacecraft named Hayabusa 2 arrived at the asteroid and successfully collected samples from it and returned them to Earth also, kind of like what they did with Bennu. Before we look into what they found in this asteroid, let's discuss just a little bit what an Apollo group asteroid is and what would happen if it were to cross close to the Earth's orbital path, just what kind of damage this might do, this kind of event could do, or could bring to the Earth. So I guess the first question would be, has this type of event occurred any time in the past? Well, yes. Of course, there is the evolutionary story. That's the standard story, that the Earth has been continuously bombarded by meteors during its 4.5 billion year history, ranging from small, dirty, or daily debris to massive, life-threatening asteroids. And of course, we don't believe that's the case because many, many scientifically sound evidences contradict that the Earth is 4.6 billion years old. We discussed a little bit of that in past classes. But if you look in past events that we actually have evidence of and we've witnessed, there have been a number of events where asteroids, comets, and meteorites have impacted the Earth. And one is very well known is a very large airburst that occurred in Siberia in 1908. That was named the Tunguska event, and it flattened over 800 square miles of forest. That's not this picture, though. We don't have a picture of that one. Other noticeable impacts were one that occurred in Thailand in 2015, and then our smaller but notable impacts were also recorded in the Soviet Union in 1947, And another one caused human injury to someone in Alabama in 1954. So yes, it turns out this type of event has happened rather repeatedly, and not that long ago. And the photo that you see here of one is one that occurred when a meteor named the Chelyabinsk meteor. My Russian's pretty rusty, so I hope I got that right. When this meteor exploded over the city of Chelyabinsk in the southern Ural regions of Russia, this happened on February 15 of 2013, and it caused some really significant damage. This meteor was classified as a Apollo-class asteroid. Here in this image, we see the meteor as a flash of light over the city, and it exploded in air, what's called a meteor airburst, at a height of around 18.5 miles above the surface of the Earth. And the explosion generated this bright flash and included hot gas and dust that was produced by this explosion. So the bulk of this object's energy was absorbed by the atmosphere, because it was 18.5 miles up. And it created a shock wave because of this blast. So this shock wave was intense. The energy was absorbed in the atmosphere, but the shock wave that was generated by this blast was estimated to be the equivalent of a blast of about 400 to 500 kilotons of TNT. So TNT, of course, is, you know what it is? It's a highly flammable compound. It's best known as being used as a high explosive, and it's used in the military, and it's used in industrial and mining applications. So a kiloton of TNT is expressed as the measure of the explosive power of 1,000 tons of TNT. So a ton is 2,000 pounds. This is incredible. I mean, you think about this amount of force here. 1,000 of these kilotons would then produce the force of 2 million pounds of TNT. So if you multiply that by 400 to 500 times, then this amount of TNT would now roughly produce about 26 to 33 times the amount of energy released in the atomic bomb explosion over Hiroshima in Japan in World War II. So we're now talking about something that's a force that's 26 to 33 atomic bombs exploding some 18.5 miles above the Earth. And so just think about that. Could that have caused damage? Well, I mean, obviously it could cause a lot of damage. And also realize that this meteor struck without any warning. They didn't see this happening. This was a 12,000-ton, 40,000 mile per hour object. And they didn't see it. They didn't realize it. They didn't have any way to predict that it was going to happen. It was a complete surprise. So the Prime Minister of Russia, his name's Dmitry Medvedev, at the time, he confirmed a meteor had struck Russia and said that it proved the entire planet was vulnerable to meteors and that a space guard system of some sort is needed to protect the planet from similar objects striking the planet in the future. And the Deputy Prime Minister then also proposed that there should be an international program that would alert countries to objects of extraterrestrial origin, also called potentially hazardous objects. So now they're afraid of an extinction level asteroid impact. And now this has become the impetus for spending literally billions of dollars to try to find and detect these ones that have a real chance of doing this type of damage again. And also now they want to find a way to possibly deflect them or alter their trajectories before they would actually strike the Earth. So in a few more slides, we're going to go over this a little bit, but I want to let you know just how damaging this meteor strike could be, or was, and that there are others that could potentially strike the Earth in the future. So here we see in this image the shattered windows in the foyer of a drama theater in the city of Chelyabinsk. And on the day of the impact, Bloomberg News reported that the United Nations Office for Outer Space Affairs has suggested the investigation by creating an action team on near-Earth objects. So this is a proposed global asteroid warning system, warning network system. So as the result of this impact, two scientists in California proposed a directed energy weapon technology development as a possible means to deflect potential asteroids from possibly striking the Earth. So later then in 2013, NASA began an annual asteroid impact simulation testing. Here's another image. Lost my pointer there. Here in this picture you see some of the damage that was done. This is a factory in this city. It collapsed the roof of this warehouse. This is a zinc factory.
Steve, is that just shock waves destroying it, or is it actual contact of material?
That's the shock wave. This material didn't actually hit that building. As far as I know, I think that's it. This meteor damaged 7,200 buildings in 6 different cities, and 1,500 people were injured. So, again, this isn't very good. Like we talked about, Genesis 1:31 says the totality of creation is very good. Meteor that would produce an explosion of 26 to 33 times an atomic bomb doesn't sound very good to me. I mean, it doesn't sound like something that God would have created as a potential hazard to the Earth. And the basics of creation science, of course, revolve around 2 major events, the creation week and the Great Flood. So if we rule out the creation week, doesn't make sense. The likely option is the flood was the cause of this. And as we looked at hydroplate theory, we now have mechanisms that are scientifically sound, following the laws of physics, that we know how these things will form. So this is the only other option that we have.
Excuse me, you just keep going. You think your battery's dying.
Oh, no, not again.
Don't bother me, just keep going.
That's okay, all right. So now we'll go back to Ryugu again, this asteroid. So after making measurements and taking samples, the Hayabusa 2 spacecraft left Ryugu for Earth in November of 2019, and it returned the samples back to Earth on December 5th of 2020. And once again, these samples showed the presence of organic compounds, such as the 4 components found in RNA, short for, again, for ribonucleic acid. They also found in these samples was vitamin B3, which is commonly known as niacin. There are 3 forms of vitamin B3, which are converted in our bodies to form what's called NAD, which is a coenzyme central to metabolism. You never remember all this, but it's an essential part of our metabolism. So metabolism is a set of life-sustaining chemical reactions that occur within living organisms. And one of the main functions of metabolism is the conversion of energy in food to a usable form and processes. Oh, we're good to go here? All right, back on again. More technical problems, sorry about that. And it's required for human life. So scientists, once again, like those samples found on Bennu, they also found that it contained a variety of different amino acids, again including 14 of the 20 that are used by living things to produce proteins. So again, how did that get there? There are around 500 known different types of amino acids. Also in this asteroid, it was discovered to be made of about 4 to 7% water. So again, fits again with fountains of the great deep bursting forth, including water would have accreted into making these asteroids. And again, water would have turned to ice, and it forms kind of a glue holding all this together. You know, there's some gravitational forces doing it, but it acts as a weak glue holding it together. So mainstream scientists continue to be shocked by these findings that indicate a history of liquid water on Bennu and Ryugu. even stating that both asteroids must have come from the same unknown watery world for which there's no evidence again. So they think they came from the same, quote, watery world of some sort, but they never say what this watery world is. They never produce any evidence of what it is or where it is or how it would have happened. But again, we see this is the stuff we find here on Earth. So what do the evolutionists conclude from all this? Without God or a creator, where do they propose that life came from? Surprisingly, they have an answer. They propose that life originated in outer space and somehow seeded the Earth with the basic elements of life that somehow became living creatures by random chance. And this is an idea known as Panspermia. It's a form of two Greek words, pan meaning all, and spermia meaning seed or life. So this is where all life came from, right? That's why it's termed Panspermia. Right? Missing from their narrative, however, is any discussion of how these amino acids and nucleotides could self-assemble themselves in the vacuum of space and near absolute zero temperatures. Even on Earth, under very controlled ideal conditions, all the experiments attempting to demonstrate something called abiogenesis have failed. So abiogenesis is the concept that life can somehow arise out of non-living chemicals. But that's never been witnessed. They've experimented under strict laboratory conditions, and even with those conditions, they can't do it. They can't even come close. All we ever see is something called biogenesis. Biogenesis is basically, all we ever observe is that life only comes from pre-existing life. We see, everything we see that's living has come from some life before. And as you go back in time, causes and effects, there had to have been an initial life, a beginning to all that. And that's, of course, answered in Scripture for us. But the concept of panspermia really seems like a rescue device for evolutionists who now realize that 4.5 billion years, which is the supposed age of the Earth, is really insufficient time for random chance to produce this kind of complexity. So in other words, that's still not enough time. In other words, mathematical equations have been done where even 4.5 billion years or 4.6 billion years isn't enough time for this stuff to randomly go to. And in fact, if you do mathematical equations, it gets to the point where it's way beyond the realm of even possible, just from mathematical equations. So here they think, again, outer space. I'm going, really? We must first realize it doesn't really solve this origin of life question. It just pushes it out beyond somewhere out in outer space. I mean, it's out there somewhere, right? It just pushes it out where it conveniently can't be observed or tested. It's only assumed to have happened out of necessity, and this is something called circular reasoning. You can't test it. So the same issues with the origin of life from non-living matter is the same issue anywhere in the universe. So realizing the origin of life by random processes is an unsolvable problem, has forced evolutionists to arrive at some really bizarre conclusions like this. So a man named Sir Francis Crick, he was the discoverer of DNA, and he received knighthood and a Nobel Prize for his discovery of DNA. But Crick was an atheist, and he found the idea that there's an intelligent creator to be quite disagreeable. He didn't like that. So in spite of his beliefs, he had this to say, which is a pretty interesting quote. He says, "An honest man, armed with all the knowledge available to us now, could only state that in some sense, the origin of life appears at the moment to be almost a miracle. So many conditions would have to have been satisfied to get it going." So he's not quite ready to say it's a miracle, but it's almost getting close to being a miracle here. That's not how science works. I mean, he's not the only person who proposed this. Others have had this idea that life has always been present in the universe and that it travels from planet to planet as bacterial spores or something else. But that doesn't work for several reasons. First, science fiction writer Isaac Asimov pointed out that experiments showed that ultraviolet light would quickly kill such spores. UV light is much more intense in outer space, and other forms of radiation would kill off microscopic spores. So that doesn't even work. For more complex forms of life, there are additional problems to work out. These include, of course, the nutritional requirements that most organisms need, the lack of oxygen, sub-zero temperatures. It just doesn't make sense. So again, the odds seem to be against this scenario here. So going back to Ryugu, we see that this composition, as we look at this is an animation. It's actually the actual asteroid. We see what? What does it look like?
Dirt clod.
Looks like a pile of rocks, doesn't it? It's a rock pile made up of many smaller rocks and dust held together by ice. This is exactly what Dr. Walt Brown predicted as the process of hydroplate theory. Evolutionary Big Bang model cannot explain how an asteroid, previously thought to be solid rock, could be instead rock piles, loosely packed together with many smaller rounded boulders. How would this come together in outer space? It takes very special conditions for something like this to form, as we talked about. They have to all be traveling at the same direction, same speed, and their gravitational forces would cause them now to come together and accrete.
See, I've got a question, if
Yeah.
that's okay.
Yeah.
So, the scientists are saying that this has been ejected from somewhere in space, and it is passing by our Earth.
Yeah, their concept basically is it's some fragments of some unformed planet or exploded planet.
So like you say, why is it so hard for them to accept that if it came from somewhere, it came from a planet, why is it out of the realm of possibility for them to accept that then it could come from Mars too?
Well, because they're committed to evolution and they don't want
The farther away it is, the easier it is to comprehend that that came
Yeah.
from somewhere.
Yeah. Yeah, it's amazing to me. I mean, you look at this and you go, this evidence seems so clear-cut and so strong. But typically what ends up with evolutionists is they basically, if there's anything contrary to their theory, they typically just ignore it. Or they try to explain it away with some rescue device.
So that came from an Earth billions of miles away, or light years away, but not this one.
Yeah,
Yeah, okay.
somewhere out there.
Wanna make
You
sure.
never know. It's like comets. You know, there's some imaginary cloud out there. We talked about before spitting out comets, you know, because comets don't last long enough to still be here if the universe is billions of years old. They would have all disintegrated by now. It's the same thing. They have to come up with some kind of answer somewhere. So this is the answers they come up with. It's crazy. So again, this asteroid is a bunch of loosely packed, smaller rounded boulders. We'll talk about how they get rounded too. Okay, we've seen what the evolutionists believe about the origins of life on our planet and the finding of organic materials on these asteroids. So what do the major creationist organizations say about this? So there are several mainstream, really good, actually, organizations that are creation-based organizations that are not advocates of the hydroplate theory. And why, I'm just still dumbfounded as to why they can't see this. So what do they say about the discoveries of these organic molecules and amino acids and DNA fragments on comets and asteroids? So the two of the major creationist organizations are Answers in Genesis and the Institute for Creation Research. And they're really both really excellent resources of scientific information and evidences supporting creation. They do a lot of really good work, and I know that they're made up of very, very dedicated Christians who obviously are earnestly seeking for truth. But in this area, I think they're mistaken. So they do acknowledge the presence of these materials and provide compelling reasons for why these discoveries do not explain how life began. That makes perfect sense. Life is way too complex to have these little fragments somehow create all life. However, they don't provide any explanation for the dozens of unusual findings on comets and asteroids, except to say that they must have been part of God's original creation, or what is found in them is the result of contamination of the spacecraft. Okay, so prior to launch, there must have been some contamination that was introduced into the spacecraft that contaminated the samples. Right? Or when it came back, somehow the samples got contaminated. So after returning to Earth. So if you consider the extreme measure of caution that you would think they would have taken, they've spent, I mean, millions and millions and millions of dollars to go out and do this kind of thing. you think they're going to take a chance? They're not going to take like extra special precautions to not contaminate the samples they're bringing back? I think they are. I mean, there's a preponderance of evidence to the contrary. So I don't think that's the answer. I mean, it doesn't really make a whole lot of sense that these were contaminated. So again, I think this is just, they don't have another answer, unfortunately. They reject hydroplate theory. They think, therefore, this must have been part of God's original creation, which, again, striking the earth and causing this kind of damage doesn't seem very good, so that doesn't fit. It doesn't seem to fit at all. So they also would have to acknowledge that God created these asteroids with abundant liquid water at some time in the past in a near perfect vacuum of space. So, and also with organic matter on it. So I guess the question would be, why would God do that? Why would he put fragments of amino acids and nucleotides on asteroids that he creates? Again, it doesn't make any sense. So it's natural. Unfortunately, they're kind of denying, they're actually kind of helping evolutionary thought along with this to an extent. They refuse to acknowledge the possibility of comets and asteroids being of terrestrial origin and as a consequence of the flood. So we're going to continue on. They continue to promote something called catastrophic plate tectonics. We'll get to that. And I heard the bell. I know we're out of time there. I wish we had more time. You know, you guys want to be here for another couple hours? I mean, there's just so much to go through. But I appreciate your attention and your attendance. And if any questions, just let me know. Appreciate it.
You didn't get to the video.
I didn't get to the video.
I'll do you.
I'll do it next week. There's too much to cover.
Thank you, Steve.
We'll get to it. There's a great video. I'll get to it. So.